Okay, so we've done decimals, we've done adding, subtracting decimals, we've done dividing and multiplying decimals. Now we're about to move into this fun thing called fraction. What's a fraction?
A fraction is...
What's a fraction?
Nine factors.
So what else? That's a fraction?
And a number that is not a whole number.
A number that's not a whole number?
A mixed number.
Give me a mixed number, yeah. So obviously I'll tell you a little story. I ordered pizza. It was a really good pizza too.
You want this friend? And then I had no anchovies on it.
It had
Anchovies on
the pizza had
Anchovies.
cheese,
No.
pepperoni,
Anchovies. No. Don't you put that.
sausage,
Anchovies. No.
extra sauce.
No. Anchovies. Can you write anchovies
No.
down? No. I like anchovies.
Pineapple.
Yes. Anchovies. No.
Anchovy.
Why is no wrong? No one ever likes no anchovies.
It had all this stuff on it, okay?
That's anchovies.
It was nice, it was hot, it was steamy. It was perfect. Everything was great. It was great, it was wonderful. I had a whole piece to myself. I had some breadsticks, some hot wings, Coca-Cola. I had me a nice movie. Had the whole day, the evening free. I was good.
I'm eating now.
So the pizza got here. When the pizza got to my house, my sister called and said, "Hey, I'm coming over." I said, "Okay, I'm coming over to bring, a picture of the wedding dress that I want you to see." I thought, "Okay, cool." So she gets there and she says, "You know how somebody come to your house and you're like, okay, I'm going to hide my food, I want you to get in my food, and blah, blah, blah." You know how y'all been there before.
Yeah.
Yeah. So y'all put the pizza and, I put it in the stove. And okay, when she leaves, I eat my pizza. So she says, "Man, it's going to smell good." So you get the wedding dress. She's like, "Damn, I'm so hungry." I was like, "What you got in the kitchen to eat?" I'm like, "You cooking anything? Girl, you got a whole pizza in the stove?" Like, "Can I have a pizza?" I was like, "Okay, come on." Grab a chair, pull a chair, do a plate. So I cut her a slice of pizza. Guess what she tell me?
Is that big enough?
That ain't fair. I should the same amount of pizza you get. So I said, "Okay, fine. You get the same amount. We'll split this pizza in half." So we split the pizza right down the middle. So now, first we had, what did I have first? Like what pizza? A whole pizza. But first my pizza was a whole pizza. One whole pizza. One whole pizza. Now all of a sudden, she got what?
Half.
And I got a what?
Half.
Half a pizza. She took half my pizza. See? One half my pizza. So, we sit down. I slice the pizza in half. I cut it right down the middle. Okay, here. You sit down, grab something or whatever and get to eating. So, all of a sudden, her husband called. He's like, "Hey, babe, I'm starving over here at work." She was like, "Oh, man, why you still on this?" So he like, "I'm coming over for my lunch break." "Man, why'd you do that?" "Girl, you gotta feed my husband." "Well, you feed with your own money, your pizza then." So her husband gets there and he's like, "Okay, I'm so glad y'all come out some pizza." He was like, "Hey, can I have a slice?" I was like, "I come with a slice of her half." She said, "No, that ain't fair. I want the same amount that y'all had." So me being the nice person I am, I said, "Okay, fine.
34.
I'll never invite you over my house when I'm eating something."
No. You will. I just
So, all of a sudden,
34. No, it's 33.
I gotta. Anyway, so he wants the same amount of pieces that we had. I was like, okay, fine. Here, pull the chair, get your plate. Now, at first I had what pieces?
A whole.
And then I had what pieces?
Half.
Now what kind of pieces do I have? 1/3 of a piece of pizza. I'm mad right about now.
That's children coming.
Okay, so we sit down.
You're hungry.
I'm hungry. I'm starving, hating all day, and I'm like, okay, fine. Okay, pull the chair. I pull the chair. I'm pouring me some Coca-Cola plastic, a nice tall glass of ice, and all of a sudden, doorbell rings. Who is it? But one of the dancers. She comes around like, oh God, please. She's like, well, I need some help with that dance, whatever. I'm not sure how to do that. I'm like, she's like, damn, I can good up in here. What you cooking? I'm like, damn, man. So she comes in and she's like, oh, yeah, that pizza. I was like, yeah. Let me get it. She wants like, yeah, please. I was like, okay. It's not fair for them to have 1/3. Us to have 1/3. And she had a slice. So I'm like, okay, we're going to split the pizza.
Again.
Well, like, so first I had what?
Oh.
Then I had
Half piece.
Then I had
1/3.
Now I got
1/4.
A fourth of pizza.
Mine is bigger. I'm
You
supposed
had
to be really nice because no way I'm sharing my food. I'm gonna be like,
I'm really nice. I'm out.
I'm not nice.
So now, all of a sudden,
Are we going to 1/8?
I got a fourth of pizza. Let's walk up to the table. My table. Eating my pizza with cheese,
only have
pepperoni
one
sausage,
slice.
extra sauce, pineapples, and anchovies. I'm like, okay, look, this Papa John's, so they give me some garlic sauce. So I'm like, look, okay, I'm gonna put my garlic sauce on my pizza, and I'm about to eat whatever. And now all of a sudden, I'm knocking on the door cut. Little bad kid from across the street. Well, just one of them. He came, he was like, excuse me, can I have some sugar in water? I'm like, yeah. I want to he's like, yeah, Mommy not home yet. I was like, okay, let me get your sugar for you real quick. Mommy not home and I ain't had to eat at school. I was like, okay, fine. So, you ain't gonna eat? I'm like, no, I got some cereal. I can't eat cereal. I'm allergic to milk. I'm lactose intolerant. Like, man. Pizza, you got some pizza? Man.
Yeah, cheese on it.
Hold on.
Hold on.
Don't eat anything, y'all. Oh, here comes this little boy.
Hold on, he's lactose intolerant.
Yeah, cheese on
Thank
it. You. So what they gonna tell you? What they tell you about him?
Right.
So at first I had what?
Cereal.
A whole. Then I had
a half.
Then I had
1/3.
Then I had
1/4.
Then I had
1/5
of a piece of pizza. Here.
Just say, everybody get it.
Half, right? Now split it off now.
Looks like it just happened for real.
Now I have.
Why would you just keep talking
Yeah.
Yeah.
And one more. 1, 2, 3, 4 was right here. But I can't even draw it easy. I'm not a draw artist. So. But anyway, it went on and on and on until it finally got to 1 tenth. And I mean, it made me so angry because I'm like, I spent all around with the pizza and I was like, it's not even the point of me eating anything.
Who all came over to eat pizza?
I mean, it's people, like, at first it's my cousin, then my sister, then my brother. And it was just really irritating. I'm like, I'm starving, y'all.
What about Little Caesars, $5 pizza?
That's what I should have
Did
said.
y'all fiance come over though?
You did.
Mario came over.
Okay, so y'all get the picture, right?
Yeah.
That's what fractions are. They just keep dividing and dividing and cutting in half and cutting in half until you can't cut it in half anymore. When you can't cut it in half anymore, what is it called? What form is it when you can't do anything else with that fraction? If I keep going here, I'm cutting this all in half. I can never deja vu. I think I've read it before. Y'all heard deja vu? Yeah. Weird, huh? So, I mean, I keep going here and here and here and here and here, and all of a sudden I can't split this piece anymore. What do they call when that fraction is down to the point you can't take it anywhere else? Whole number, well, it could be.
Mixed number?
Mixed, could be.
Oh, wait, I know this.
It's in its simplest form.
Oh, yeah.
You can't take that fraction down anymore. It's in its simplest form. And how do you get to the simplest form? What's that word? It starts with R.
Reduce.
Reducing. You reducing. You know how you go to the store and you go, if your parents take you to the store, I don't know, but I'm sure they probably do. If you go to the store with your mom, you're looking you go to the dairy section, you're looking at the milk, and it has a whole milk, and it has 2%, it has skim milk, and it has fat-free milk. Whole milk has nothing taken away from it. It has all the milk fats, it has all that kind of stuff in it. So I don't drink whole milk, because I think it takes more, but I drink 2% milk. 2% milk only has 50% is wonderful. 2% milk only has a 2% of the fats and everything in it.
I think a little of the blue top.
That's 2%.
Yeah.
That's what happens. When you have a certain whole number, you keep reducing, till the point it has absolutely no fat at all, which is called fat-free milk. It's almost like water because it has no fat in it at all. It's gross enough. So yeah, simplest form is when you, a lot of times when I give you different formulas or different problems to solve as far as adding, subtracting, multiplying, dividing fractions, I always tell you to first of all get the simplest form. You get the simplest form by first of all, most of the time you take it and you multiply or you divide the fraction by the, most of the time they call it the least like. Least common number, you go through that word a whole lot. You want to find out how to get there. So that's what we're talking about factorization. And you have two types of number. One is called a prime number. Prime number. And the other is called a composite number. Prime number. Can anybody guess what a prime number would be? How about I give you an example? How about I give you an example of a prime number and you can tell me what it is? 1, a prime number. 3. That's, now you see my odd numbers. Even though 3 is 1. 2, 3, 6, 5, 7, 11, 13. These are just a few examples, but from this, if you think about what does 1, 2, 3, 5, and 11 all have in common, like why would they be called a prime number in terms of multiplication? A prime number is any number when you factor it out. The only thing it has, the only factors it has is the number itself and 1. That again, Mike, again. The number itself and 1. That's the only factors it has. 1 times 1 is 1. It's no other number for me to get 1. I can't multiply any other number to get 1. 1 times 2 is 2. I can't multiply any other number to get 2. 1 times 3 is 3. No other numbers. 1 times 5 is 5, and 1 times 11 is 11. So why can't I put 6 up there? I heard somebody say 6. Why can't I put 6? Is 6 a prime number?
Yeah, wait, 6 times 6.
Right. Well, I mean, what other, 1 times 6 is 6, but what other numbers can I multiply to get 6? Come on, I know, you ever get it. Come on, David, you ever get it.
13?
What other numbers what 2 numbers can I multiply to get 6?
To get 3, 2.
3 and 2. 3 and 2. Which means it's not a what? Prime number. What other numbers can I multiply to get 8?
4 and 2. 4 times 2.
What number can I multiply to get 12?
Wait, 4.
4? No, 4 is 2 times 2 is 4.
4 times
3
4. 4 times 4 is 4 times 3.
No. See, what you have to do is the number. You have to figure out what number you have. And factorization, you have a factor tree. So you go here, you put 1 and 11. Okay? Can I break 11 down any more than that? I can't. If I have a We said 4. Can I say 4?
Yeah.
Okay. If I had 4, right? I have 1 and 4, and then what else? I can break 4 down.
2.
2 and 2, and how can I break 2 down?
1 and 1. Did you say have 0?
It's really nothing. Because the reason you can't break, you can do 1, 2, and all that, but you just want to do the numbers that equals to 4. So 1 times 4 is,
4.
and 2 times 2 is,
4.
yeah. That's what that means. So what's the opposite of a prime number? If that's the case. What's the name of the number that you can multiply? It has more multiplications than just 1 in itself. Composite number. Composite number has numbers you can multiply. It's not just 1 in itself that you can multiply to get itself, which is 12. What's the factor? How would you factorize 12? First of you do what? You always do that with that first. 1 times the number itself. Now do 12 for me. Go ahead.
6.
6 times.
12.
Then.
3. 2.
Yep. That's the way you can factor that out. You can also do what? 4 and what? 4 and 3.
4 and 5.
4 and 5 is 20.
4 and 5.
What is your example? They need 100 in this. I'm looking at 100 right here. And it's called, this method is called prime factorization. You can be on page 186. So without looking at the book real quick, let's do 100. Yeah, don't look at the book though. And for this one, you will not do do those blank numbers. Ready? What two numbers is equal to 100 besides 1 itself?
25.
5. Good. And then?
Then
Right here? 2 and what?
Is it
Times 4?
3.
4?
2.
And then?
5.
Okay.
5. Then it's 0.
So, you can actually, that's it. You've already factored it all the way down.
Are we doing prime factorization homework?
Yeah.
Can we maybe say this?
What? But y'all got worksheets. So what is this right here called? What is this whole thing right here called, or what?
Prime factorization.
And what is this diagram called?
The tree.
A factor tree. So if I want, it's this, a 100, because it's such a large number, it has two ways you can factor it out. So the first two that Desmond gave, 25 and 4, those are factors of 100. What's another 2 factors of 100 that you can think of?
50.
50. Very good. 50 and 2.
Then 25 after 50. Under 50. And no, 2.
Okay, you bring this down.
And 25 to 5. And that.
And
2.
5 and 2, 25.
5.
What do you see happening?
It's the circle of life.
Same thing?
Huh?
The factor of 5 times 5 times 2 is 100, 5 times 5 times 2 times 2 is 100. We can do another factorization.
Can I do another board?
What's another we can do at 100? It's not in the book. What's another one?
Wait, we gotta sit down.
What's another one?
10.
100. 10, I'm listening.
Oh, 10 and 12.
12.
I didn't get 10. 10 and 10 from all the questions. 10 and
Okay.
10.
10 and 10.
Yeah.
Alright. Factors. I'll say this again. Factors are what the two numbers you can multiply to get one number. Prime numbers only have the number 1 in itself that you can multiply, nothing else, which is 2, which is 1 times 2. When you factor something all the way out, you get to another prime number, which is called prime factorization. So here, I can't break 5 down anymore. I can't break 5 this down. I can't break 2 down anymore because it's nothing but prime number. It's the number 1 in itself. So a factor tree, if I actually do prime factorization, what you will do is you will multiply everything out and you will break it down until you get to none of the prime factors. Are you listening?
Mm-hmm.
100. What's two numbers you can multiply to get 100? 10 and
25 and 15.
10 and 10. 10 and 10 equals what? 100. What two numbers can I multiply to get 10?
5 and 2.
5 and 2. So I will take this, 5 times 2. Now I'll take this, 5 times 2. And what do I actually get in essence? Same prime factorization. How's this?
It's all the.
You got it?
100.
You got it? You sure? Well, tell me what I just did then. I got it.
Just said, what two numbers can make 100 and I think.
Well, what's the goal of prime factorization? To get to what?
So the end.
Simple. What's in the end?
The prime number.
Prime numbers. Yeah, that's the whole point of prime factorization or factor tree is to get those. If you're going to need a factor tree, do you know why you need a factor tree?
That's right.
When you start doing fractions, you can easily get at least common denominators. You can easily start reducing fractions. That's why you need a factor tree. So once you start actually knowing how to reduce fractions or how to do this without even doing a tree, it'll be easy to reduce those fractions because you can just pop it in your head. Okay, you can pop it in your head. Let's do something in the book. Number 1 on page 186. 186, number 1. It says, complete the prime factorization. I don't see y'all like y'all sleep on it.
I know this. Okay.
And look at your book. Look at your book.
Okay.
Page 186, number 1. It says, complete the prime factorization. 12. So I'm going to just go with Micah. She's right there in the front. 2 times blank times 3. What number is missing from there? What you could do is do what? Factor tree. So do the factor tree for me. What's the breakdown do?
So when you do a factor tree,
Hey.
4 and 3.
Okay, very good thing to start with. 4 and 3. You got it. What two numbers can you multiply to get 4? Mm-hmm. And what two numbers can you multiply to get 3? It's just a prime number, right? 3 prime number. So what number will go there? Yep. Got something like that?
So 3 times 2 is 4 times 30.
It's 12, right? Look at number 3. It has 81 equals 3 times 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 blank. So I want to do a factor tree. I don't know why I wrote this all over here. I'm going to do a factor tree for 81. What two numbers can I multiply to get 81? Right top of your head.
Huh?
What two numbers can I multiply to get 81?
9.
9 and 9. And then can I break this down too?
3.
Yep. And
3.
yep. So what number is this there? Oh, it's good.
Can I do it?
Sure.
3 is 27 times 3. What? Can I do number 2? I'm going to do number 2.
Number 2. 2 times 5 times blank equals 70, right? Okay, so I'm going to factor out what number?
70.
70.
Ooh. Put your hand down. You sure ask the question. Oh, okay.
What two numbers can I multiply to get 70?
5.
Times what? Yeah.
In my head.
Okay. We're talking about 10 times 7. You going, I mean, it's good. I'm glad you did that one. You going,
Now I'm trying to see what the number.
Final prime number? Is it?
Yes.
Yes. 14 a prime number?
Nope.
Nope. What two numbers can I multiply to get 14?
2 and 7.
What's the number missing from there?
No, 14.
No.
7.
It's not prime factorization yet.
10 times 7.
Yeah? Did you get it okay?
Simon time. Where it go? I say you want to do number 4.
Simon!
4.
Glad you picked that one.
With the expo. Wow.
Y'all like X on it?
Nope. What is expo?
You like X on it?
What's the no on it? I do all of them. I like exponents, but I need to refresh on that one too.
Let's go here. 2 to the blank power equals 16. So what number are we factoring out, Simon?
The blank power.
What number are we factoring out? When you think about exponents, all they are is just a shorthand way of writing numbers. And instead of writing a number 10, 15 times, you just put blank for the 15th power instead of writing out 15 times. It's just a shorthand. It's shorthand for math.
What is an exponent?
All right, Simon.
8.
Yep.
Yeah. Oh.
Do a prime number?
Yeah. Why we got the colors wrong in school? 2. 2 and 4.
Do a prime number?
Yeah.
Do a prime number? 4 prime number?
Wait, yeah. Wait, no. 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 That's probably almost never come out.
How many 2s do you have?
2. 1, 2, 3, 4.
So it's 2 to the what power?
4 power. Yeah, 2 times 4. You got that right? 2 times 4.
Did you get it? Did you get it?
When you do your thing, when you do your prime thing, and you get your prime, and you count all the numbers.
Listen, whenever you see an exponent, that's the number, that same number that many times. Yeah, not 4 times 2.
4 times 4.
It's 2 times 2 times 2 times 2. If I had 2 to the 100th power, guess what that means? 2 times itself 100 times.
It's a
2 times 2 times 2 times 2 times.
What times 2 is that? 8 times 2, 16 times 2. Yeah. 30. 30 times 2. Four. Ooh, it's 4. What? 247. What time is it? 8.
Okay, so if you need to, if the instruction says write the prime factorization in exponents, then you know how to do that. So how would you do 9? And tell me, represent.
Okay, you would do 1, 3.
1.
Not in
You
mine.
never start with a 1 when you're doing this. 3 times.
3 times.
So it's what's the exponent?
3. 2.
2. Right. Well,
How's it 2? No, so you count both from 3.
so it's 3 to the second power equals
9.
So finding the least common multiple. You use factorization to find the least common multiple. Who knows the least common multiple?
Me. So I do multiple.
It's just what it is.
The least common multiple.
So if I have 9 and 30. Okay, and then find the least common multiple on page there's 187, right? Okay, so I have 9 and I have 30. Somebody factor out 9 for me.
Me. 3. 3 times 3.
Somebody factor out 30 for me.
5 and 6. 5 and 6. 5 and 3. 5 and 6.
And you can't do 10 and 3, right? Keep going.
And then 6. 5 is a prime number.
Okay.
And then 6, 3, and then 2.
Okay. So I have these are my factors. So I'm gonna compare the factors of 9 with the factors of 30. What is the least common multiple out of all of these? What's the lowest number? 2. It'd be a 2. That's my least common multiple. Yeah, that's how I like little balls.
Okay. Let's do it. Can I try a fraction on the board? You give me a fraction because I know you. Me too. You give me a fraction? Me too. No, me 3. I said me 2. She's fine. Me 4. You didn't say nothing. I'll meet 1. Me 2. Me 2. Me nothing. Sorry, next. 6 is.
Okay, hold on. So I'm not liking it. I don't like it at all. Because right here it's saying you have to multiply.
Yeah.
Okay, well, we're going to do this then because
What, this common multiple?
we want to do that until tomorrow simply because you have to use a calculator to do that. You don't have to,
I need some letters.
but it's just faster to use your calculator. Because right here they're saying at least common multiple of 4, 9, and 50 is 900. So what they're saying is that you have to factor out 4, factor out 9, factor out 50, which you would get 2 times 2 times 3 times 3 times 2 times 5 times 5. Multiply everything together, and then you get 900. They have the least common multiple out of 9.
You said 2 times 2? I'm glad we're doing this tomorrow because I ain't bad with mine. What did you say? 2 times what? 2 times 2?
Since we have to do our presentation, I'm going to cut this short today.
So we're
Yeah,
going to do it tomorrow.
Well, you're going to still have the, you just need to do the prime and composite number homework. Yeah.
Okay.
Yeah.
So you're what is it in?
Yeah. So obviously you get that. So we'll do, tomorrow we'll do the, we'll start from morning, do the greatest coming factor, and we'll keep going with the calculators because I can't be rushed to this far here. But tonight for homework you will have.
So we gonna do the prime and composite stuff tonight?
Yeah.
I know what equal stuff. We're telling us to do anything. Yes,
well, hold on. Because you can do this one. Look on, here's your homework a little bit.
Look on. We don't have no thing. Look, Miss Joy. I know equal to 40, 11 plus 11 plus 10 plus 8. Our ages.
That's the good. That's the fine. Okay, listen. Come on, Simon. Sit up. Take it off your head.
I'm cold.
Take it off your head.
Yeah, it's not cold.
Okay, look at page 26. And it says a factor is a divisor of a number. For example, 3 and 4, we got that, right? Are both what? Factors of what? 12, right?
4. Where you at?
The very top of the page. It says a factor is a divisor of a number. For example, 3, 4 are both factors of 12. So a common factor is a divisor that is shared by 2 or more numbers. 1, 2, 4, and 8. The greatest common factor is the largest common factor shared by the numbers, which is 8. Okay, y'all got that?
Yeah. What are the common factors?
To find the greatest common factor, 32 and 40 list all factors of each. So we're going to do this together real fast.
So we about to do this back?
So if it says, if you have to find the greatest common factor, 32 and 40 list all the factors of each, okay? So we'll do this together. Ready? Somebody factor out 32 for me.
8.
4.
Oh, yeah. 4.
And
4 is the 7. 4 is the prime number. Oh, no. Prime factor.
Yeah.
What's the prime factor?
Okay.
2.
Is the prime factor? 4.
2.
2 times 2.
And 8 is 4 times 2. 4 times 2. And then 2 times 2 with the 4. 2. And then it's 0.
No 0. No. It's right there. Okay.
It's 5.
So with this, if I ask you to factor it all the way out, that's what you do. Y'all hear me? If I ask you, this is the difference. Listen, this is the difference. On page 25, it says identify each number as prime or composite. On number 3, part A, it says use a factor tree to find the prime factorization of each number. This right here is what you call a prime factorization. Right. Okay, y'all got that?
Yes.
Which means this is what you do on numbers what? 3 and what?
4 and
3A and B and 4A and B. Y'all got that?
Yes.
Yes?
Yes.
Y'all got that?
Yes. So we're going to do the factor tree.
Now listen, the factor tree is only here where it says use a factor tree.
I don't see that.
Bottom of the page. Use the factor tree. You see it, Michael? Yes, y'all see that? You see it? Okay. All you're doing for number 1, 2, 1, A through C, and 2A through C is doing what? Identify each number as what?
Prime or composite.
And what's a prime number?
Prime number.
Only factors are what?
By themselves.
1 and it.
2. Wait. 1, 2.
So on page 26, this is what you need to do and know how to do for tomorrow. We're gonna go straight through for we're gonna start doing fractions and find at least the
and fractions. I call dividing and multiplying fractions.
Okay. So on page 26, when you're trying to find the greatest common factor, you're not gonna write this because this is when you're doing what? Simon. What is this?
Tree.
Tree, what kind of tree?
No. It's
Factorization. You know, they don't have page 6. You have to do this on page 26. But these are the factors of 32. 8, 4, right? 2, 1, and 32. Okay, so all these, well, I mean 1 times 32. You always know that a factor, always know that each number has at least 2 factors, which is 1 itself. Okay, again. Always know, y'all not listening. Always know that a number always has at least 2 factors. 1 and itself. If you can't factor that out for you can't find any more factors, then that's a prime what? Number. That's why I put 132, because it's always understood. Okay, you don't have to do that for the factor tree. So right here. So what are the factors of 32?
32, 8, 4, 2, 1.
I guess I'm going to
32.
32. Okay, let's factor out 40.
4, 11.
140.
Hey, 10.
11.
10. 4. Then first time number.
It is?
I mean, what's that called?
2,
2 times 2.
2, 5. This is how we do a factor tree. Okay? But what are the factors? All the factors. Only when you have 2 times, you have many 2s, and you have to put that. Okay?
2.
Okay, 2.
1.
1.
40.
40.
10.
10.
3.
You see 3 of them?
No, that's it.
4 and 5. These are all the factors.
Where's
1,
5
2.
at? Right there. 4. There's 5. It's the bottom. They're like a 3. Looks like a 5.
What's some more numbers that can equal to 40?
Wait, what?
What's some more numbers that can equal to 40?
11. 40.
11 is not.
11 plus 11 plus 10 plus 8.
Say again.
You already have it there.
What?
8. 8.
8.
No. 8.
Another one. Another one. 20 times 2, baby?
It was what?
40?
Yeah, oh yeah. 20, no, 30, 11, 10
Let
times.
me show you either way to do this. So, let me show you another way to do this. You ever have a factor tree, right? Get a factor tree?
Yeah.
Can you get the factor tree? Okay. So, if on a test I say find the greatest common factor, what are factors? Numbers that you multiply to get that number. Am I right? Okay, so let me show you easy way to do this, like they did on page 26. 32. What 2 numbers can I multiply to get 32?
1, 8, and 8.
1 and 8. 1 and 8, really?
And 4.
1 and 8.
4 and 8.
1 times what equals 32?
32.
What other 2 numbers can I multiply to get 32?
8 and 40.
What other 2 numbers can I multiply to get 32?
2, 16.
Really? Yes. And 2. Any more? Any more? What about factors 32?
32. 8.
All up here. That makes it easier to do.
8. 1.
1. So the way what you want to do is go from smallest to greatest to great. 1, 2, 4, 8, 16, and 32. Let's do 40. What 2 numbers can I multiply to get 40?
10 and 4 times 4.
First, let's do 1 and 40. 1 times 40, right?
Mm.
Okay, what's the next
2
one?
times 20.
2 times 20.
1 times 10. 4 times 8.
4 times 10.
5 times 8.
5 times 8.
That's it.
It is.
What?
Sure?
What? No, it's not. It's a.
Yeah. And what's the factors of 40?
1, 2, 4, 5, 8, 10, 20, and 40. And
So, what is the greatest common factor? What's the biggest number that both of these numbers share?
32. No.
Think before you say something.
8.
That's your greatest. That's your GPO. Your greatest common factor.
Okay.
Let's do one of these on your homework.
So we doing our homework in class?
No. Let's do one. All right. So 1. Number 1. 8 and 12, and it says, what are the factors of 8 and 12? First of all, let's see the factors of 8. So I draw my little bracket right there. What 2 numbers can multiply to get 8?
4 times 8.
1 times 8. That's when you want to start with, right?
4 times 2. 2 times 4.
4 times 2 or 2 times 4.
8 times.
That's it, right?
Yes.
What are the factors of 8?
1, 2, 4, 8. And 8.
12. What 2 numbers can multiply to get 12?
1 and 12. 1 times 12.
Good.
2 times 3. 2 times 6. 4 and 3.
I heard 4 and 3. 3 and 4.
4. No, nothing.
Is that it?
No. Yes, it is.
Yeah.
Yeah. No.
So what are the factors of 12?
1, 2,
Yeah.
3,
Yeah.
4, 6, 12.
What are the common factors? Not the greatest common factors. What are the common factors? What are the common factors of 8 and 12?
3. I mean 2.
We're going to do what? 1.
2, 4, 5.
Anyone?
8. No.
My common factors are 1, 2,
4.
4. What is my greatest common factor?
4. Yeah, 4.
You do another one? You do another one.
Wait, what about common factors?
Huh?
Common factors.
1, 2, and 4. That's the common factor.
Factors. What about factors?
Factors, you do each number. These factors of 8 are 1, 2, 4, and 8.
So you write that?
Uh-huh. Right beside the number.
This is going to be super easy.
Let's hope so.
Don't write that.
We'll do one more. We're going to do one more.
Oh, so I'm writing on my homework.
One more. Let's do number 3. 24 and 15. What 2 numbers can I multiply to get 24?
1 times 5. Mommy, 1 times 15. 1 times 24.
What 2 numbers? 1 times 24.
2 times 12.
3 times 12.
3 times 8.
3 times 8.
4 times 6. Yeah.
4 times, very good. 4 times 6, make sure you get all of them out there.
That's it.
Is that it?
Yeah.
Y'all see that?
Yes.
Okay, so what are my factors of 24?
1, 2, 3, 4, 6, 8, 12, and 24.
Oh. Let's factor out 15. What 2 numbers can I multiply to get 15?
1 times 15. 1 times 15. 2. No, 3 times 5. 4. No, that's it.
What are my factors of 15?
1, 3, 5, 15.
Now what are my common factors? Look at my common factors.
1 and 3, 3.
1,
3.
3.
That's it.
Any more?
No.
So my common factors are 1 and 3. What's my greatest common factor? 3.
3.
How do you feel about that? Extremely simple?
Yes.
I think it is too, Simon.
Common factors are 1 and 3.
That's all you have tonight.
What is great common factors? 3.
It's the biggest one of all the factors.
And factors are, that's common?
That's the greatest common.
Oh, okay, great.
1 and 3 are common. Why? I look over here, I see 1 and 3, and I look over here and see what? 1 and 3. This one will have 5. This one will have 4. This one will have 2. This one will have 8, 6, 8, 12, 24. So what are my common factors?
1 and 3. Your common factor
1 and 3.
Greatest common factors.
How are you doing? You doing okay?
Yes.
Pretty good.
Like 1 and 3, and that's not even a question. Oh Lord.
All right, young people, we're gonna get prepared to start. Get ready to do your
Can I put her wings on her head now? Never. Wait, I need my bag. I need my big ball. I told you my bag. I don't need you to touch me, Danny. Oh. You don't know what you don't want to know.